going to be giving a presentation on streaming telemetry. So a quick introduction. In this presentation, we're going to explore the history of network management in SNMP, examine the weaknesses of SNMP, give an overview of what streaming telemetry is, describe its advantages, and show use cases for what and how it can work. So what is streaming telemetry? In its most basic form, streaming telemetry is a new approach for network monitoring in which data is streamed from devices continuously with efficient and incremental updates. But before we get too deep into what streaming telemetry is, it's helpful to know the history of network management, SNMP, and how that came to be that telemetry was invented. So network monitoring history, at its bedrock, SNMP has been kind of the main stable force in network monitoring the last 30 years. So it was created in 1988, and really it was designed to solve the problem of these massive networks growing and expanding at exponential rates. It wasn't just one or two computers, it was hundreds and thousands. And the issue was, how do you effectively gather information, monitor these networks, and then push configuration changes? Also, it allowed for simple operations to either change states or gather information, like we said. So say you wanted to check the CPU status of a server or firewall or a network switch, SNMP could be used for that, as well as make changes to whether that be a network switch interface or something else on your network. Also, another component of SNMP was the fault management piece. So there could be certain thresholds that you could set, say that CPU status or CPU utilization at the head's above 90%. Trap could be configured, and then that alert would be sent to SNMP. Also, SNMP is an IETF standard, so that greatly enhanced its adoption as well. And then as it matured, different versions were invented as well. So SNMP v2, which is defined in 1993, which had community strings, which was essentially secret strings that for authentication, and then SNMP v3, which is defined in 1998, which added enhanced security and encryption. So SNMP operation at its base uses managers and agents. So on the picture to the left, you have firewall, you have a Linux server, Windows server, a printer, and router as well. And the agents would be embedded in the operating system of those devices. And then the manager would be the monitoring server here, which would be a dedicated server that would have software that would collect that information. So the managers then are responsible for polling and querying and receiving traps. So contrary to telemetry, SNMP was very reliant on polling and querying. So say I wanted a piece of information about this printer, the monitoring server, or the collector, it would pull that printer, maybe for just if it was out of paper or something like that, and then that printer would respond to that collector. And lastly, the agent tracks the status of MIB objects. So we'll get into this in the next slide, but this is really how it would track what piece of information SNMP was looking for. So SNMP heavily relied on the MIB tree. So in this example, the identifier we have is 1.3.6.1.2.1.2. And basically what that points to is what piece of information is SNMP looking for. And how that's defined is basically a tree-like structure that once you get down to a certain piece of information, that's what you're looking for. So in this case, you start at the root, and then you'd branch out, and you keep branching out so you get down to interface. And say you could even say interface state if this went down one further. Each branch then is essentially tacked on to this MIB string identifier, and that's how SNMP knows what specific piece of information we're looking for. SNMP has really been extremely helpful, and it's still heavily used in environments today, but it's not without its faults. The two primary deficiencies that it has is that SNMP is more reactive rather than proactive. So with the nature of SNMP, using polling and time intervals often associated with that. It could be 60 seconds, it could be 2 minutes, 5 minutes, and if an issue happened in between those polling cycles, sometimes you could miss it. To overcome that, a lot of network admins and security engineers, they'll tighten up SNMP, so they'll increase the polling. But the downside of that is when you do that, CPU load and resource utilization on the device spikes. So as you can see from the graphic on the left, telemetry offers capability to send a lot more data than SNMP. Also, as you crank up SNMP to increase that polling interval, SNMP increases the CPU load while telemetry stays relatively stable. And then also you can see the time to collect the data is a lot more efficient with telemetry compared to SNMP as well. So what is streaming telemetry? As we talked about at the start, basically it's a new approach for network monitoring. The data is delivered more efficiently. It allows devices to only subscribe to the data they want, and it leverages incremental updates. So contrary to SNMP, telemetry is push, not pull. So like we said with SNMP, if the collector wants a piece of information, it'll query what the device, and then the device would compute that and then send that information back. With telemetry, you define subscriptions at the start, and then once the device has that subscription, it automatically sends that data without the collector asking for it. So it's a lot more efficient in that sense. Also, it can send a lot more data than SNMP, which makes it very useful for analytics. And then lastly, with the standardization of how it represents data, it's data model driven. So that's very helpful for the collectors, and then whatever the whoever's getting that data can then manipulate it and see it in a lot better sense. So as we talked about, the telemetry data structure, it uses Yang for its data modeling. That data, once it's in the Yang data modeling format, is then encoded into either JSON, XML, or GPB. So an example of Yang here on the left, just hierarchy of how the data is represented. Like you have interfaces, and then you have the interface itself, and then you have, similar to a tree-like structure, a few leaves off that for statistics, IPv4, IPv6, and then address under the IPv4 and IPv6 as well. Kind of take a more granular look at that. With the graphic here in the center, you have the IETF interfaces, interface, and then you have a list of read-write attributes that telemetry could either inquiry about or change the states of. Then under that, you have the interface state, and then same thing there, kind of a leaf list of read-only attributes that telemetry could gather information about. How is telemetry delivered? There are three main components with it. You have transport, encoding, and the protocols in use. For transport, the devices can deliver the data using SSH or HTTP or HTTPS. For the encoding, that's going to be primarily JSON, XML, or GPB. And then the protocols, depending on the protocol stack that's in use there, would be netconf, RESTconf, or gRPC. So kind of as the graphic here to the right identifies, if you're using netconf, the encoding would be XML or SSH. If you're using RESTconf, the encoding would be JSON, and then HTTP for transport. And if you're using gRPC as a protocol, GPB would be the encoding, and HTTP/2 would be the transport. So on top of how it's delivered, there are also two different types of session initiation. You have dialing in which the collector initiates the session to the router and specifies the subscription. The device sends whatever data specified by the sensor group in the subscription requested by the collector. Also, you have dialing out, where the device initiates TCP connection to the collector and sends whatever data specified by the sensor group in the subscription. So really the differentiating point between those two is who initiates that subscription. With dialing in, it would be the collector who initiates that subscription, and then with dialing out, it'd be the device. But true to telemetry in its nature, once that subscription is defined, the collector doesn't have to query or poll for that information. The device knows that subscription is there and automatically sends that data. So there's two different types of streaming telemetry methods. You have cadence-driven and you have event-driven. Cadence-driven would be something that's more tied to time interval. So say you wanted to know the CPU utilization of a server or a network firewall switch, and you wanted to know that every 30 seconds. That's would be how you define this subscription. and then that network device would send that data on that time interval. Compared to event-driven, so this would be somewhat similar to an SNMP trap. So say there's a mounting errors on the interface, or say there's a route change on your router. You could configure that subscription to listen to that activity, and then once that threshold is surpassed, that would cause telemetry to send an alert to your collector. So streaming telemetry collectors, there's a few different kinds. You could have custom stack. So an example of this would be an ambitious developer in your environment who maybe they made a homegrown web application and they're sending telemetry data to a database, and then that data was represented in that web application, however would be useful to the company. You also have open source tools. So a few popular ones out in the field today would be GRAFANA, Elasticsearch, GRAFANA, and then Panda. And then on the commercial stack side, this would be a proprietary tool, something like SolarWinds that you would pay a vendor for, and they would supply you with the software with a lot of pre-built functions within it. So a few examples of streaming telemetry collectors. This is what Elasticstack looks like. Elasticstack is extremely popular out in the field today. It's more used for basically sending a ton of data to, and then it's enhanced search capabilities to dig through that data and find what you're looking for. It does have some dashboards that you can customize to maybe show alerts or errors on certain things, but its main function is the data collection and data searching through it. Also, on the open source tool side, we have GRAFANA. Contrary to Elasticstack, GRAFANA is more for the data visualization side. So say you wanted a nice place, kind of open pane of glass to take a look at your network and see if there's any errors, see if there's anything that really jumps out to you. You could send the telemetry data to Grafana and then fine tune these dashboards to give you a much easier and better look at your network too. And then last but not least, this would be an example of one of the proprietary tools. So this is SolarWinds. SolarWinds is extremely helpful network monitoring and management tool as well, especially when its updates don't contain malware. But even with that, it's extremely heavily used in Fortune 500 companies and government agencies as well. This is an example of what a telemetry configuration would look on a Cisco router. In this case, we'd be using gRPC. So at the top, you define your telemetry model. You'd list the destination group, add the IP address of the collector with the port you're using. With it being gRPC, the encoding would be GPP, and then the protocol would be gRPC. Down towards the middle, you define your sensor group, and then the sensor path. This is exactly the piece of information that you're looking to get from the subscription. So compared to SNMP, which had the nice kind of long ambiguous SNMP mid string, this tells you more information on what exactly the type of information you'd be getting with this subscription. And then lastly, you'd name your description down here, add the sensor group to it, and tag the destination group that we defined up here. Lastly, some telemetry use cases. A lot of people see the long-term roadmap for telemetry being something that could eventually surpass SNMP. SNMP is still heavily used in a lot of networks today, but there's growing support for telemetry, and the thought is eventually that telemetry will surpass SNMP in its entirety. Also, just with the sheer amount of data that telemetry can produce, it's very helpful in predictive load capacity planning. So say you're taking a look at your data center or maybe your MPLS links or your internet links, and you want to see what the bandwidth utilization is today and what you can plan for 6 months from now or a year from now. Having that data can be very helpful for things like that. And lastly, a lot of people find it useful for custom analytics solutions. So especially on the security side, just with the enhanced amount of data that you're getting, it gives security operators the ability to take a look at any anomalies in the network, maybe detect malware as it's traversing throughout your network. It can be an extremely helpful tool for them as well too. So in conclusion, we gave an overview of the history of network monitoring in SNMP, described the deficiencies of SNMP, examined what streaming telemetry is and the different collectors that can be used with it, and we gave some examples of use cases. Any questions?